We're starting off with IGCSE's topic of angles, and whatever comes under angles is going to be mentioned over here. I'm going to be going through them one by one, and I'll make sure that I share some examples and share some practice questions as well so that you get a good hang of it. So, calculate the unknown angles using the following geometrical properties. When the syllabus mentions angles, these are all the things that you're supposed to know. The first thing is angles at a point, right?
Yeah.
Angles at a point, what do they refer to? Imagine we've got this angle. Come again?
Oh, the 360 view.
Perfect. This is a point. So how many degrees of angles exist at this point? If I were to draw a vertical line going like this, how many degrees can it turn before it reaches the same place? It can turn a total of 360 degrees. How many degrees do we have at the point? We're going to say 360. That's the entire concept of angles at a point. Angles at a point. Does that make sense?
Yeah.
All right. I would recommend keep on taking notes. Keep on taking notes so that you don't have to go back and view it again. But otherwise, I will have it uploaded on YouTube. You can always go back and view it. So angles at a point, we just did that. It's a circle, or in other words, a 360-degree angle. Angles at a point on a straight line and intersecting straight lines. Now, under this category, we've got two more angles. Angles at a point. What point are they referring to? I'll mark it with red. Can you see this point? Wait, let me mark it with black. This is the point that they're referring to. Angles at a point. And they're on a straight line as well. Which straight line? This blue straight line. Keep on taking notes.
Yeah.
A and B, they not only exist at one point, but they're also on a straight line. What property do we have for such angles? Both of these angles, when added, will take us all the way up to how many degrees?
180.
180 degrees. Simple. That's which color is this? All right. That's the concept of angles on a straight line. We're done with that too. That's only the first part. They add up to 180. What is another word for numbers that add up to 180?
Supplementary.
Perfect. Well done. And now we're going to do the second part, which is an intersecting straight lines. Whenever we have intersecting straight lines, have we drawn that over here? No. Intersecting straight lines would look like this. A line is supposed to have, by the way, two arrows because it's never ending in both directions. These are two intersecting straight lines. Now, referring to this angle, since we're studying the topic of angles, angles formed between two intersecting straight lines are these. I mean, you can also wonder why we're not taking part C or D. We can study them too. So angle A is equals to angle B. Why? Because they are
intersecting.
And once angles are never intersecting. The lines happen to be intersecting. Angles are vertically opposite. In such a case, when we've got two intersecting lines, we've got vertically opposite angles. I've given you a pair of angles A and B. Can you give me a pair of angles?
C and D.
Perfect. I can also mention that C and D are going to be equal. Now, what's very important is that you should be able to recall this concept when a question pops up. Okay?
Yeah.
Let me go back here and highlight what we've done. Intersecting straight line is done as well. And I'll make a small note over here of vertically opposite angles. Angles formed within parallel lines. Now that's, do you remember the acronym we made for this, or mnemonic?
Yep.
What's it called?
It was Vika.
Vika. Perfect. Now, what does Vika refer to? Vika refers to all those starting letters of the words that are that are hiding between these letters. V stands for vertically opposite. I stands for,
Interior.
well done. C.
Corresponding.
A.
Was it allied or angle?
Almost there. Alternate. Alternate. Now, vertically
Oh,
opposite. Vertically opposite. We're done with, right?
yeah.
In fact, you can remove V from here, but then the mnemonic would lose its sound. I cannot call it Ika. So let's let it be there. We were done with. V technically does not fall under parallel lines. It falls under two intersecting lines. So that we're done with. Amongst parallel lines, we only got three letters, and they are I, C, and A. Let's discuss them. No, a transversal is just a line cutting those parallel lines. What parallel lines are we talking about?
Yeah.
What color are they in? Parallel lines are lines which never
which never meets. Never.
which never meet. Well done. So this line 1 and this line 2 would never meet.
Yeah.
But the line that does meet them and cross them at two different points is called a,
Cool.
familiar with this?
I'm not sure.
What do you call this? It's up here.
Transversal.
Transversal, right? This pink line
Yeah.
is a transversal. Now, whenever two lines intersect, what do they form?
Transversal. Oh, no.
What topic are we studying?
Angles.
Angles. So whenever two lines are
Oh,
going whenever two lines are gonna meet, take a look over here. Whenever two lines are gonna meet like this, here we go. Wait, I'll just use basic lines. Whenever they'll meet, they'll make an angle. Does that make sense?
yeah.
Since the two lines that are meeting over here are one's in pink, this one, one's in blue, this one, and they'll meet and they'll make multiple angles. In this case, they're making multiple angles. I'll choose this one and I'll label it A. Now, this is a property which, after a lot of what do you call? With a lot of proof, you can prove that this A is going to be equals to another angle, and that's B. Right?
Yeah.
So instead of going into that proof right now, I would just want you to memorize these as it is. What I can, however, tell you is that these are called alternate angles. To alter something means to
change.
To change. Now, what are we changing over here? If I were to make or give it four spaces, four locations, what is the angle A at? Location number?
Bottom right.
If I were to give all of these four angles, four locations, if I were to give them four numbers, angle A is at which position or which number?
Number 4.
Number 4. Right, directly opposite to number 4 is which angle?
A.
No, right opposite to number 4, we've got the number
1.
Number 1. If I were to completely change its position, wouldn't I say if I were to completely change its position, angle A would be at 1 instead of 4?
Yeah.
All right. If I were to completely change its position and say that it's up here, and make sure, and instead of writing it up there, write it down over here, wouldn't it exist here? Since you said number one is obviously, if it's up here, it's going to be here. Number two is going to be here. Number three is going to be here. If we were to match their corresponding positions, wouldn't number one be available over here?
Yeah.
Does that make sense? I mean,
Yeah.
we've got four set of angles down here. We've got four set of angles up here. And if I were to draw all of their matching positions, let me do that. If one is up here, where is two gonna be?
Next to it.
Right next to it. Where's three gonna be?
Below number one.
And four is down here.
Yeah.
Now, if I were to alter A's position and completely alter it, what's right opposite to position number four? Number one, right?
Yeah.
Now we are supposed to make a connection between the angles of line 1 and angles of line 2. So completely opposite to this angle A is going to be this angle down here, right?
Yeah.
Does that make sense?
Yeah.
So angle A is going to be equals to angle B. Okay?
Yeah.
There's a lot of proof behind it when we can throw in numbers to prove that they're going to be equal, but we're not going to be studying that for now. We're just going to remember the rule for now. We're going to be doing examples a little time from now. Can you give me another pair of angles which are going to be equal and they should be on the inside of these two lines? Below this line and above this line. Can you give me another pair of angles which might be equal, which might be alternative angles?
2 and 3.
Excellent. We're going to say angle, let's call it C. Angle C is going to be equals to angle D. Or we can also call it angle 3 is going to be equals to angle 2. Just like you said. Does that make sense?
Yeah.
Okay. We're done with 2. We're done with V. We're done with I. We were done with V in intersecting lines. It doesn't fall under parallel lines. Let's go on to corresponding angles. Now, if I were to give numbers to their corresponding positions, if you've got angle A over here, and I also label it position 2, I'll label this position 3 and position 4. What corresponding positions do we have down here? If we were to label them with numbers, which one's going to be 1?
And top left.
Top left. This is 1. And this is going to be? Look, if 1 is in this position up here, in these 4 angles,
it'll be 2.
This is going to be 2. Perfect. If you've got 3 down here, where would 3 be over here if we were to draw them exactly as they were up there?
Bottom left.
Bottom left. Well done. And I'll label this 4. This is 4, right? Now, corresponding means, what's another word? What's a synonym for corresponding? Starts with M.
M.
Yeah.
I'm not sure.
Matching.
Oh, yeah.
Right?
Yeah.
Which position does A correspond to in the in this set of angles?
3.
That's vertical. No, I doubt that. Think again. We're done with alternative angles. We're done with alternate angles. We're moving on to corresponding angles. So what's the corresponding position to angle A? But it should be down here. So you have to make a link between this angle and one of these angles down here.
Would it be 4?
Ollie, let's talk in terms of positions, right? If I were to label this position as top left, what is this? Sorry, top right. What is this position going to be?
Which one?
This one.
Wait. Top right.
We're already done with top right. It's at the top and it's on the right. What is this position going to be? It's at the top and it's on the left. Does that make
Top
sense?
left. Yeah.
Right? What's this position going to be called? The 4 angles, we're just giving them names in order to be able to refer to them. Can I call this bottom left?
Yeah.
And can I call this bottom right?
Yeah.
I mean, I tried the numbers, but it didn't work, so I'm giving them another name, right? So the angle A up here is at the top right position. Which angle down here is gonna be matching to the position of angle A?
Top right.
Top right. It's gonna be over here. So if I label this angle B, since they both have the same position, they both have the top right, they're going to be
Be equal.
equal. Well done. So we're done with C as well. But however, I would want you to come up with some other possible positions that might be equal to each other. So we've established that A is equals to B.
Yeah.
What other angles can possibly be equal to each other?
C and D.
C and D, and where are they going to be?
Maybe on top left.
Top left over here and top left over here, right?
Yeah.
I'll give you 2 more sets of angles, E and F, G and H. Which ones are going to be equal to each other now?
It's loading. G and F and E and H.
G and F, E and H. Well done. Now we're actually done with C as well. We're just left with A to go. Okay?
Yeah.
Here we go. Wait, hold on. Hold on. We're done with A. We're done with A. We did that right at the start. Remember, we discussed alternate angles. A stands for alternate. We skipped I. I is at the end. I is at the end. Where's I? Here it is. Here it is. I refers to which word?
Interior.
Excellent. Interior. And interior happens to be on the
inside.
On the inside. So we've got both of these angles. If you take a look, A is on the inside or on the lower side of these 2 parallel lines, and B is also on the inside of these 2 parallel lines. Had it been out here, it would have been exterior. But
Yeah.
exterior angles do not exist over here. We don't have a rule for exterior angles. Interior angles do have a rule. And instead of being equal to each other, they add
up to make 180.
Excellent. They add up to make 180, and the word for that is
Supplementary.
Supplementary. Well done. Okay?
Yeah.
Word for that is supplementary. Now, if I were to discuss them in terms of their positions, this is at what position? If you were to discuss its geographical location, what would you describe it as?
Bottom right and top right.
Bottom right and top right. Some students refer to as C angles. I don't prefer to use this method. If it helps you remember, sure, but I would not recommend this. And this sometimes referred to it as F angles and Z angles, but let's not go into that. That's going to get more confusing. Now we're actually done with all 3, V, I, C, and A. Does that make sense?
Yeah.
Here we go back and let's take this off. I hope I'm not going too fast.
No.
All right. Angle properties of triangles and quadrilaterals. Let's skip this for a moment. and jump here. Angle in a semicircle. If I were to erase half of this circle, what am I going to be left with?
Semicircle.
A semicircle. Now, if using the diameter of the semicircle, do you know what the diameter is?
Yeah.
The line extending from here till here, right?
Yeah.
This is the diameter all the way from here till here. Using the endpoint of the diameter, if we're able to make another angle out of it, and that angle happens to go right to the circumference and then come back to the other end of the diameter, this angle is also going to be how many degrees?
90.
90. Let me quickly go back, mark that off. In fact, we've already done that. What's this property called? This is the radius. The radius of a circle happens to be the line from the center to the
To the end of the
and the term for that is
radius.
nope.
Oh,
I
the
mean,
tangent.
no.
No, the tangent's the line.
What is the blue line called?
Circumference.
Circumference. And this pink line that we have up here is called the
Tangent.
tangent. The radius and the tangent meet at how many degrees?
90.
90 degrees. So this is going to be 90. And another word that we have for this is perpendicular.
Yeah.
But perpendicular refers to lines and not angles. So when we're discussing lines, we're going to say they're perpendicular to each other. But when we talk in terms of angles, we're going to say it's a 90-degree angle. It's a right angle. Does that make sense?
Yeah.
So here we go back here. Quickly to mark that off. Angle between a tangent and a radius of a circle. By the way, let's take down quick notes. What should I write down over here?
That the radius, the angle of the zor is 90 degrees.
No. Watch closely. I'm marking this.
Oh. It's perpendicular.
Angles formed within parallel lines. We just discussed them a little while ago. They're weaker.
Oh. Yeah.
And since we're already done with V up here, I'm going to remove that and just be left with I, C, and A. Remember? Now, the topic that you were just doing, angle in a semicircle, how much is that?
90.
90. Angle between a tangent and a radius of a circle, how much is that?
Also 90.
Also 90. Let's move on to the next one. What's the property?
Angles in the same segments are equal.
Nope.
Oh, and it's twice the angle of the circumference.
Well done. Angle. All right. I'll give you the proper words for it as well. Imagine I've just drew a black line. Did you see that?
No.
Yeah. I'll draw it again. Here you go. Did you see it now?
Yeah.
If I were to call this is the technical name for this is a chord. But if I were to call it a cinema screen, please do not write cinema screen in your exam. Just an example. Okay. If I were to call it a cinema screen and there happen to be tons of seats over here, everybody's sitting over here trying to watch a movie. Okay. So the guy sitting at this position and the guy sitting at this position, how can we relate each of their angles. What's the angle size gonna be of the guy sitting at this point, which is the center O, and the guy sitting at the circumference of the circle? What relation can I make between their angles, the angle that they're able to watch the screen at?
Um, they're gonna
Do you know why people do not prefer to sit closer to the screen at the cinema?
because it's like too much to view at the same time.
It's too much to view at once at the same time. So the guy sitting at the point O, his angle is going to be twice the size of the angle the guy sitting at the back.
Yeah.
Now, what's the official term for it? The angle at the center is twice the angle at.
The circumference.
Excellent. I'm going to mark this off. Take a look over here. So one by one, you're getting done with your topic. We've done quite a few. There's a few more to go. Okay. If you need a break, let me know.
Yep.
We've got another rule over here. I'm going to erase some of the lines and start all over again. So we've got another chord over here. What's a chord, by the way?
It's the line that separates the two segments.
Excellent. Well done. So we've got a minor segment up here. Minor segment. And this entire thing is called the
Major segment.
major segment.
Music.
Major segment. Now, if I were to ask you which segment do these angles A and B belong to, what are you going to say?
Major segment.
Major segment. So what's the official phrase that we can use for this? Angles A and angle B happen to be in the
Same segment.
same segment. And what's the rule? If they're in the same segment, they're both going to be
Equal.
equal. Now it's a little difficult to understand why that is so. In order for that, we're gonna be labeling this chord. Right? If two angles subtend from the same chord, what do I mean by that? Take a look at the screen if you're not watching. I'm gonna draw an angle here. An angle is always formed by drawing two intersecting lines, right?
Yeah.
When I make these two lines intersect, which angle forms over here? It's already labeled for you.
A right angle.
What's the letter inside it? We've already written the letter inside. Angle A. And if I were to draw another angle which, hold on. Let me erase this. Now take a look. If I were to draw another angle from the same endpoint of the chord, which angle forms over here?
B.
B. So angles in the same segment would refer to angles A and B, and the property that we have for that is that they're going to be
Equal.
Equal. Is it making sense so far?
Yeah.
All right. Let me go back, cross it out. By the way, up till here, this is the same course. Those of you who are watching it on YouTube, once I've uploaded it, this is the same course that you have for O levels as well. All right, angles in the same segment are equal. That's done. So we've done with quite a few subtopics of angles. Now let's go to the next one down here. Imagine we've got a circle like this. Okay. And we try to fit in a square box in the circle or any quadrilateral inside the circle. The angles that are going to be exactly opposite to each other, they are going to be called what sort of angles?
Um,
Supplementary, remember?
supplementary, yeah,
And why do we call them supplementary?
because they add up to 180.
They add up to 180. Another way of remembering this is when we've drawn a circle, they've called it a cyclical quadrilateral. They've called it as, remember this with this from cycle. Since the cycle's tires, bicycle's tires, they happen to be round. When you're fitting in a quadrilateral, four-sided shape inside the cycle's tire, it's going to be called a cyclical quadrilateral. If I refer to this shape as cyclical quadrilateral in the future, just know that I'm referring to a box which has happened to be fit into a circle. Does that make sense?
Yeah.
Okay. Now the rule for this is, the official terms for this are angles in opposite segments are
The supplementary.
supplementary. Well done. Or in easier words, they add up to 180. So angle A and B, they're going to add up to 180. Now, how do we know they're in opposite segments?
Because the chord is separate.
Excellent. The chord is separating them. So angle A happens to be in
The major segment.
major segment, and angle B happens to be in the minor segment. They're equal. Can you give me another pair of angles which might be equal if the chord were to be drawn like this?
The ones opposite each other, or like
Let's label it C and D.
Yeah.
So if I were to write a rule like this, what will I write?
The angles in the opposite segments
Are
are
supplementary.
supplementary.
And if I were to make an equation out of it, it would look like C plus D is equals to
180.
180. So you're done with the 5 rules for, what do you call them? Angle properties of circles. Angles in opposite segments are supplementary. Do you notice the term down here that they've used? Rida?
Yeah.
What's the term that they've used up down here?
Cyclic quadrilateral.
And if I remember, I just told you a little while ago, if I refer to it in the future, what does it mean? What is a cyclic quadrilateral?
Is it a shape that has 4 sides? Quadrilateral.
Quadrilateral is a shape which has 4 sides. What is that? What does it have to do with cyclic?
No.
We've got less than a minute, so I'll tell you how did this cyclic quadrilateral term form. This is a bicycle up here. The word cyclic comes from cycle, and if I were to fit in a box inside its tire, it's gonna be a quadrilateral. So cyclic quadrilateral. That's where the term comes from. Does that make sense?
Yeah.
Okay. So we're done with quite a few of the subtopics. How many left to go?
I think that
1, 2, 3. 1, 2, 3, and 4. We can quickly do them as well. Now, there's another one over here that says alternate segment theorem. Alternate segment theorem is what we have in IGCSE course, but we do not have that in O-level course. But we can discuss that nonetheless. So imagine we've got a tangent like this. Okay.
Yeah.
And we've got a triangle inside this shape. And that happens to look like this. So the angle formed between the tangent and the circle over here another angle formed in the alternate segment, they are going to be equal to A is going to be equals to B. And the term that they've used for this is alternate segment theorem. What is alter? To alter something means to change. What is alternating? The alternate segment.
Like as it's changing.
Or two different segments, right? One's in the minor segment and the other one is in the
Major segment.
major segment. Can you say that if I were to ask you which segment does angle A exist in, what are you going to say?
Wait, which angle does segment? Oh,
Angle A.
the minor segment.
Minor segment. I'm glad that you were able to decipher that I was referring to this chord without me mentioning it.
Yeah.
Right? This
Yeah.
line happens to be the chord, so I will mention it over here. This is the chord. How do I know this is the chord? I mean, all three of them are chords, but when I'm referring to alternate segments and I'm referring to two angles which happen to be in different segments, then we are obviously referring to this line as the chord that I've just labeled. So A happens to be in the minor segment, B happens to be in the major segment. Their angles in the alternate segments. One of them has been formed through a chord and a tangent, and the other one has formed inside the triangle, which is right opposite to it. I mean, there's no better way of describing it. Just for this, except for the fact that they're in alternate segments, they're going to be equal. So that's property number 6. Okay.
Yeah.
Similarly, can you come up with another pair of angles which might be equal? And they happen to be in alternate segments. I'll label everything that I have over here and see. Let's see which ones do you choose. Which two angles happen to be in alternate segments?
E and C.
E and C. I hope you're taking down notes because when a question, I'll have to refer back to one of these properties, so you can quickly go back into your notes and see what I'm referring to. All right.
Yeah.
Now we're just left with three more subtopics to go, and we've still got 11 minutes. Angle properties of triangles and quadrilaterals. That's a part of angles as well.
Yeah.
The property that we have for angles. For that, you first need to know what a polygon is. A polygon is?
The polygon is a shape with 3 or more sides.
Perfect. Any shape which has 3 or more sides. So a triangle, a quadrilateral, a pentagon, they're all, and so on and so forth. They're all polygons.
Yeah.
So when we're referring to a triangle, what property do we have? That all of its angles add up to
180.
180. So if I were to label it A, B, and C, I'm going to say they both add up. They all add up to 180. And then another rule that we have that you should know, I think it's important under angles, is to know what sort of triangle this is. Since every angle inside it is an acute angle, it's less than 90, it's an acute angle triangle, right?
Yeah.
If one of the angles is right, it's a right angle triangle. And one of the angles is bigger than 90, it's an obtuse angle triangle. Does that make sense?
Yeah.
So angle properties of triangles, done. Make sense?
Yeah.
Now let's go on to quadrilaterals. A quadrilateral is how many sided shape?
4.
A four-sided shape. So I'll draw a very basic quadrilateral over here. That I've accidentally drawn a parallelogram. The sum of angles A, B, C, and D is going to be equals to
Um,
A plus B plus C plus D. They're going to be equal to 360.
yep.
Just like this triangles, angles, they all added up to 180. Angles of a quadrilateral, they always add up to
360.
360. That's a rule. And I'll even tell you how that rule forms over here in a little while. So the basic motion introduction of angle properties of triangles and quadrilaterals is done as well. Does that make sense?
Yep.
I mean, there are for certain other rules, but they're kind of linked to other to the concept that we've already done. Take a quick look. If I were to tell you, in fact, they're already parallel. That's why it's called a parallelogram. If I were to say P, Q, R, and S, if side PQ is parallel to side SR, through a property that we already know, what can you say is special about the angles A and D?
The opposite each other.
Opposite angles are angles which form like this. They form between two intersecting lines. I'm talking about angles which form between two parallel lines.
Not too sure.
Interior angles, we did them a little while ago. They're both on the
Oh,
inside.
yeah.
Remember, they're both on the inner side of two parallel lines. So
So
what
they're
can you what can you say about A and D? Angle A and D, they're gonna
equal each other.
not quite.
Oh, wait. Yeah, doesn't it?
Nope. Interior angles always add up to 180.
Oh yeah, 180. Oh, I was thinking of vertically opposite.
You would think of vertically opposite. So when it comes to quadrilaterals, I mean, there are some other rules that you can use along with it, but that's mostly what you need to know. That they add up to they add up to 360. Now, angle properties of regular polygons. We're gonna be doing this now. By the way, let me label this. So angle properties of triangles. What properties did we have over here? They add up to. What do the angles of a triangle add up to?
180.
180. What do the angles of a triangle, a quadrilateral add up to?
360.
360. Well done. Angle properties of regular polygons. Here we go. If I were to ask you to the sum of the angles A, B, C, and D, A, B, C, D, and E, how will you do that?
Number of sides.
The rule for that is, I'll write that down over here. If you were asked to find the sum of angles, all of these angles, you can say sum of angles is equals to n minus 2 into 180. Now, what does n refer to?
The number of sides.
The number of sides. How many sides do we have in a pentagon?
5.
5. If I were to find the
5.
sum of sides, I'm going to just plug in 5 over here. 5 minus 2 into 180. And that's 3 into 180. And that happens to be how much? 540. Similarly, if we go back, you told me that the sum of all of these angles is 360, right?
Yeah.
Now let's put this rule to the test. n minus 2 into 180. In a quadrilateral, what's the number n equals to?
The number n of
Yeah.
4.
4. 4 minus 2 into 180. What does that give us?
360.
360. 2 into 180. And that is equal to 360. Remember this?
Yeah.
Let's try to put this rule to the test over here. Sum of angles you said of a triangle, they add up to
180.
180. How many sides do we have over here?
The 3.
So 3 minus 2 into 180. And 1
So
multiplied by 180 is how much?
180.
180. So this rule works for every
Every polygon.
every polygon. One last rule to go. If you're taking a look at the screen right now, if I extend one of these sides like this is the interior angle, right? We're not discussing that anymore. The angle that
Yeah.
forms outside is going to be called
The exterior.
the exterior angle. How do I find the size of one exterior angle?
Do the formula.
And what's their formula?
360 minus the number of sides. I mean, divided by.
Come again?
360 divided by the number of sides.
Perfect. So if I were to ask you to find the size of one exterior angle, you're going to say it's 360 divided by the number of sides. How many sides do we have over here?
5.
So for example, if you're solving this exterior angle, finding the sum of or size of this exterior angle, we're going to say 360 divided by 5. How much does that come out to be?
72.
Yep, 72. So we can label this exterior angle as how many degrees?
72 degrees.
Now, really, the questions are not going to be this simple. I'll give you an example of what it might look like. Can you read this? Can you read it out loud?
Yeah. A, B, C, D, is that one?
Right. A, B, C, D, and E, B, C, F are?
It's the part of. Oh, this keeps moving. So
Are parts of two identical regular n-sided polygons.
yeah.
Calculate the value of n. Now you must be wondering where's the polygon over here. Because a polygon is supposed to be a shape which has 3 or more sides. So they're saying they're parts of two, they're not complete. The polygons that are drawn over here, they just happen to be parts of the complete polygon. The shape that they've drawn over here is not a complete polygon. So what would it look like? If I were to complete it, it might go like this, then this, then this. Let me draw it in red. Does that make sense?
Yeah.
No, it's a complete polygon. So they're saying it happens to be a part of a regular polygon, and similarly down here it might look like this, this. Or let's give it another side. Okay.
Yeah.
That's just to give you an understanding what the questions might look like. I mean, that's one of those tricky questions that I've chosen from the past papers. Now they're asking us to calculate the value of n. N refers to the number of sides. The only thing that they had given us was this angle 30 that is left now. If this angle is 30, how much are these two angles going to add up to? What's the property regarding angles at a point?
The 360.
Perfect. So if I were to subtract this 30 from 360, what am I left with?
Just 330.
330. Now 330 needs to be divided amongst two parts, right? Over here and
Yeah.
over here. You cannot divide this 330 by 2 again to divide it amongst two
Yeah.
equal parts. 165. How do I know it's two equal parts? Take a look over here. Regular. And they both identical. They both happen to be similar polygons and they're regular. Regular means now this, let me show you what I mean by that. There can be two types of polygons. This is a pentagon, right? How many sides does it have?
5.
5. And they all happen to be somewhat equal to each other, right? This side is equal to this, they're all equal to each other. We can also draw a pentagon which looks like this.
Yeah.
It also has 5 sides, but is it regular?
No.
No, because the sides are not equal to each other. If this length is 10, I can say for sure this is also 10, this is also 10, and this is also 10, so on and so forth. But if this is 10, this side is surely not 10, right? Regular means they're both equal, they're all equal to each other, the sides are equal to each other, and identical means both same shape.
Yeah.
Following?
Yeah.
Now we've got the number 165. What can I say about the number of sides of this polygon?
Still.
That's where one more formula comes in. Take a look over here. Remember we did a formula for the number of sum of sides of a polygon? The reason why I didn't introduce it earlier is because it's a derivation of the same concept. This is for the sum of angles of a polygon. This is the last concept. Just stay with me here. If I were to find the size of one angle of a polygon instead of the sum of angles, what am I going to do? Are you with me?
Yeah.
I'm going to pick up this formula again and simply divide it by the number of sides. Then I'll just have the size of one angle instead of sum of all the angles. Okay. So we have the size of one angle that happens to be 165. I will write it down as n minus 2 into 180 divided by
Um,
the rule that we just wrote a little while ago. What's the size of one angle? What's the formula for size of one angle?
360 minus 2.
No, n minus 2 into 180 divided by n.
Oh.
I just wrote this, remember? N minus 2 into 180 divided by n.
Yeah.
And we're going to equate it to 165. Imagine, Rida, you've got 30 sweets. And you're supposed to distribute it amongst kids who are at the birthday party, and there happen to be 10 of them. 10, if you've got 30 sweets and you've got 10 kids in front of you, how many sweets would each kid get? Come again?
Just a number of sides.
No, we're discussing just another example in which we've got 30 sweets and we've got 10 kids, and you're supposed to distribute the sweets amongst the kids. How many sweets would each kid get?
Usually so 3.
3. You're going to write 30 on top. That's the total amount that you have. And you're going to write 10 down here. That's the number of people you're supposed to divide it amongst. This is the same way that this formula forms. N minus 2 into 180 is referring to the sum of all of these angles, right? A, B, C, D, and E. Does that make sense? Now, if I were to ask you to find the size of one angle, wouldn't you divide this entire thing that you have up here, N minus 2 into 180, by the number of sides, N, just like you did for those sweets? If I were to ask you to find the angle per the size of one angle, you're going to say same formula, N minus 2 into 180 divided by the number of sides. Does that make sense?
Yeah.
So we've got the size of one angle as 165. You will write the total formula up here. N minus 2 into 180 gives you the sum of all the angles. This is the last concept, to stick with me for another minute. We're going to divide it with the number n and write equated to 165, because what did we just figure out? Had it been a complete shape, size of every angle is 165. Why? Because they said it's regular. If every angle is 165, now we need to figure out how many sides it has. So we're going to use algebra to find the number of sides.
Yeah.
Let me quickly just solve it for you. This is the solution down here. I'm going to send the n to the other side and multiply it. That forms 165n. And just what we're left with on the left side is 180 multiplied by n, which is 180n, and 180 multiplied by negative 2, which is negative 360. Simple algebra from here, bring this over here, throw 360 on the other side, and solve for n. So this particular polygon had 24 sides. Does that make sense?
Yeah.
All right. Now your topic for angles is complete. Whatever I send you in the form of worksheet should be, you should be able to do it now. Angle properties of irregular polygons is just another extension of what we've just done. Regular polygons, this topic and this topic, they're linked together, nothing new. We're done with the entire chapter of polygons, I think, for the second or third time now. But this time it's complete with examples. So I'm gonna be sending you a worksheet, and that's due next Saturday. Okay. But no, in fact, send it to me at least 2 or 3 days before Saturday so that I can check it and return it to you so that we can discuss it as well. All right. Khudafis, take care.
That is.